Okay, so good day class. So today we're going to have our lecture for the third week for our plumbing subject in architecture. Okay, so we're going to discuss about the water supply and distribution system, which would be the hot and cold system. Okay, this topic is really important, especially in your future practices as architects. Okay, so I think aside from our lectures, I'm going to assign you. No, I'm going to make you make draft a plumbing plan. So a complete plumbing plan. Okay, so I'm still I'll try to communicate with the rest of the department about this. Okay, so that there's already an available assignment. I'm just thinking if I'm going to make it your PIT or I'm going to give it as a project. Okay, so I think most of you are who are under me in my previous building tech uh, building tech 2 on building tech 3 subject. You are already familiar in how to do plumbing plans. Okay, so but this time around, instead of copying something which has already been drafted and completed, um, you're going to do something from the very beginning. So you're going to use your creative juices as architecture students. Okay, so let's start our lecture with the water supply and distribution system. So the water distribution system is the water service pipe, the water distribution pipes, and the necessary connecting pipes, fittings, control valves, and all appurtenances in or adjacent to the structure or premises. So these are the parts of your water distribution system. You have first the service pipe, which is the pipe from the water main or the source of potable water supply to the water distribution system of the building served. So when you talk about the water main, so that's the line from the water district. Okay, so that's where you're going to tap. Then you have the water meter. So it's device used to measure in liters or gallons the amount of water that passes through the water service. So I guess a lot of you are familiar with water meters already in your own homes. And you have the distribution pipe or supply pipe. So there's a pipe in the structure or on the premises which conveys water from the water service pipe or meter to the point of utilization. Then you have a riser. So a water supply pipe that extends one full story or more to convey water to branches or to a group of fixtures. So when you're referring about the water supply system, you'll encounter the term risers. Fixture branch, the water supply pipe between the fixture supply pipe and the water distributing pipe. Then you have the fixture supply, a water supply pipe connecting the fixture with the fixture branch. Okay, then you have a cold water distribution system. So there's are the two types of water distribution. You have the direct or the upfeed and then indirect, which is the downfeed or gravity system and the hydropneumatic or air pressure system. Okay, so this is an example of the direct or upfeed. So water is provided by the city water companies using normal pressure from the water main. Okay, so this is the water main from the water district. This is service line is your property line, then it goes inside your house. Okay, so this is an example also. So you have here the water main. This is the corporation stop. This is a stop box. Then it goes to the building. Okay, then you have an indirect or the downfeed or gravity system. So water is pumped into a large tank on top of the building and is distributed to the fixtures by means of gravity. Okay, so from the water supply, so it goes up. Okay, so this is your tank. Okay, then it goes to the different supply uh, supply branches. Okay, so this water tank class is really important because you won't know if there are changes in the pressure of water going to the building, so and also the supply. So if there is less supply, then if you don't have a water tank, then your house won't have a stable water supply. But if you have a water tank, even if there's a change in the supply of water, you'll still be able to service the entire house. Okay, so it shows here in the diagram that uses a pump. But there are some places, class, here in Cagayan de Oro, wherein the water pressure is too high, then you don't need a pump. But it would really depend on your location. So before you start your project, the first thing is that you're gonna do is research that location if they have a good water pressure in the area. Okay, then you have the indirect or hydropneumatic system or air pressure system. So tanks that use water and air under pressure are referred to as hydropneumatic tanks or pressure tanks. Compressed air is used in these tanks as a buffer or cushion that allows a surge-free delivery process. So there are three functions for hydropneumatic tanks. The first is as part of a water delivery system set to deliver water in a preset pressure range. The second uses the pressure setting to monitor a pump from turning on too often. So the third is to buffer or lower pressure surges, much like a power surge protector. Okay, so for example, class, here in um, upper Bulwa, when you go up and you follow the road to ABS-CBN going up, okay, the water pressure here is quite high. So it would sometimes there are surges in pressure, then it really affects the fixtures here in our house as well. Okay, so like what I've said, when you do your project, you have your project someday as architects, first one of the things that you're going to consider first is to do your due diligence in knowing the water pressure in the area you're going to build your house. But of course, it would really be uh, convenient for the client if you're already included the water tank at the beginning during the design process. Okay, so these are it's called water distribution system. So the upfeed system, its advantage is that it eliminates the cost of pumps and tanks. Okay, so your pumps and tanks class, these are expensive, and one of the advantages of the upfeed system that you don't need them. And the disadvantage is that pressure from the water main is inadequate to supply tall buildings. Of course, that is true. The building is too high. Let's say it's more than 2 stories, then there's a chance that the water pressure might change. Then water supply is affected during peak load hours. So what do you mean by peak load hours? So these are the times wherein there are a lot of users. So for example, if in that area, particular area, there are a lot of users during the day, will be using the water from the water main. So chances are that in that particular house or building, there will be a low supply of water. So that's why it's really important to have tanks. Then you have the air pressure system. So the advantages is that it is with a compact pumping unit. It is sanitary due to airtight water chamber. It is economical because there is a smaller pipe diameter, then less initial construction maintenance cost. But the disadvantage is that the water supply is affected by loss of pressure inside the tank in case of power interruption. Okay, so this is affected in case of power interruption, but there are already technologies available currently, class, when you're going to use solar, so that you won't be affected if there's interruption in the electricity. Okay, fifth advantage is that oxygen in the compressed air serves as a purifying agent. Okay, so if there are some impurities, so they are being purified as well. Then it's adaptable air pressure. Then the air pressure served zone of about 10 stories intervals. Then you have the overhead feed system. One advantage is that water is not affected by peak load hour. Two, not affected by power interruptions. And three, time needed to replace broken parts does not affect the water supply. Okay? But the disadvantage is that water is subject to contamination. Okay, so this happens class if you have tanks that are exposed, and then some, if it's open, you haven't checked it, chances are there could be a breeding ground for mosquitoes, or foreign objects might fall to it, like dead animals, etc. And high maintenance cost, occupies valuable space, can require stronger foundation and other structure to carry additional load of tank and water. Of course, it's going to be expensive because when you are storing large quantities of water, it's going to be heavy. And then apart from that, you're going to have to spend more in your structural design. So meaning, if you're the builder, you're going to, have to the owner must spend more to buy a lot more materials for the concrete and the steel requirements. Okay, then the next is your hot water distribution system, of which there are three types. The first is the up feed and gravity return system. The second is the down feed and gravity return system. The third is the pump circuit system. So the upfeed and the gravity return system. So with a continuing network of pipes to provide constant circulation of water, hot water rises on its own and does not need any pump for circulation. So hot water is immediately drawn from any fixture at any time, then provided economical circulating return of unused hot water. Then larger pipe is installed at the top of the riser, and diminishing sizes passes through the lower floors of the building. Okay, so this is the diagram, or this is the source, and you have a valve here. Okay, so this is the heater, so it circulates around the system. Okay, so it says that since hot water rises, there's no need for uh, pump for circulation. Then hot water is immediately drawn, so when you open your faucet or fixture, you could immediately use the hot water. Okay, so that's the upfeed and gravity return system. Then you have the downfeed and gravity return system. So hot water rises on the highest point of the plumbing system and travels to the fixtures by gravity. For a closed pipe system, water distribution is dependent on the expansion of hot water in gravity. Larger pipe installed at the bottom of the riser, and diminishing sizes passes through the floors of the upper floors of the building. So the pipe diameter becomes smaller as it goes higher. Okay? So this is the downfeed and gravity system. Then you have the pump circuit system. So this for a more efficient circulation of hot water to the upper levels of multi-story buildings. So here we have your valves, your centrifugal pumps, and this is the heater. And you have also provision for the drains. Okay, so water is heated, and you can also control it using the valve. Okay, so let's stop at the hot and cold water distribution system for this week. So if you have any questions or clarifications, class, uh, feel free to send an email or message me anytime in my Facebook. Okay, so see you next week. Then I'll be posting the details of your activity for your third week of our course at our Facebook groups. So thank you, and stay safe.